Hello and welcome back to the 8.3 notes. This is part 4, I believe. Let's go ahead and find our particular solution to this differential equation given our initial condition here. So let's go ahead and zoom in. Now we've got this this problem where it says y prime is equal to y plus 3 over x squared. Let's rewrite this so we can do separation of variables. I'm going to rewrite y prime as dy dx, and that's equal to y plus 3 over x squared. And I want to move this y over to the other side. Okay, so I'm going to multiply by 1 over y plus 3 to both sides. And this is going to end up giving me 1 over y plus 3, okay, and I'm going to go ahead and just move my dx over to the other side, so I'm just going to keep the dy here, and then as a result we get 1 over x squared dx, okay. And so the next step in this process, we've separated our variables, now we want to integrate both sides, okay, and on this side, this is a little bit tricky. This actually involves u substitution. The antiderivative, I'll go ahead and just show it to you. It's the natural log of the absolute value of y plus 3, okay? Let's go ahead and kind of do that real quick over here. If I integrate 1 over y plus 3 dy, then I'm going to let u equal y plus 3. So then I get the integral of 1 over u, and then, you know, I've got this dy here that I need to get rid of, and so if I find du dy, I'm going to get y, or I'm just going to get 1, and I'm going to move that dy over to the other side, and so I get that du is equal to dy. So it's a pretty simple substitution, but that integration can kind of be a little bit tricky sometimes. So you end up getting 1 over u du, which gives you the natural log of the absolute value of u, which just gives you the natural log of the absolute value of y plus 3. So I wouldn't just go ahead and skip this substitution. There are a few bit of tricks to it sometimes, especially if you have a negative y value, because that affects your derivative up here. So when you have something like this, I recommend doing the u substitution just to check to make sure that you have the correct antiderivative, but that's that. Okay, let's go ahead and I'm going to rewrite this, this right side over here because I don't have a rule for this, but if I integrate, instead of 1 over x squared, if I write it as x to the negative 2 dx, then I can take that antiderivative, all right? So as a result, I've got the natural log of the absolute value of y plus 3, okay, is equal to, and if I take my antiderivative, I'm going to get x to the negative 1, and then I'm going to divide by negative 1, my new exponent, plus c, okay? So let's rewrite this part on the right. So I've got the natural log of the absolute value of y plus 3 is equal to negative 1 over x plus c, okay? Now, my objective at this point is to solve for y. So it's in a log form, or natural log form. Let me rewrite this as log base e of the absolute value of y plus 3, and that's equal to negative 1 over x plus c. All right, now I want to get rid of the log form and put this into exponential form. So e is my base. I'm going to take e, that's going to become my new base. This part over here becomes my new exponent. So I end up getting the absolute value of y plus 3 is equal to e to the quantity, negative 1 over x plus c, okay? Now, the same thing applies to what we did before, all right? I need to simplify this and rewrite this. So I've got the absolute value of y plus 3 is equal to e to the negative 1 over x power times e to the c power, okay? And that's because if I were to simplify this part right here, okay, I have the same base, so I would add my exponents, and that's that step here. So we're going backwards here. All right, now if I take e to the c, Okay, that's a number raised to another number. This is a number. This is a number, folks. So this is going to become the big C, okay? So let's rewrite this now as the absolute value of y plus 3 is equal to the big C times e to the negative 1 over x, okay? Now, at this point, now that I have my big C, I'm going to get rid of this absolute value. Now remember, to get rid of the absolute value, I get y plus 3 is equal to plus or minus the big C times e to the negative 1 over x power, okay? And so as a result, and this is the part here where I like to choose whether we're going to use the positive big C or the negative big C. So if I come up over here, I have to look at my y value, okay? And so because my y value here is positive, so I'm going to write that. Y value is positive, okay? So choose the positive C value, okay? And so that's kind of the choice that I make right here. And so, and you can even go back and, I'm just going to go ahead and choose it. So I'm going to choose the positive C, okay? And so then I can write y plus 3 is equal to just the big C times e to the negative 1 over x. And so now I can subtract my 3 from both sides, and we're going to end up getting y is equal to negative 3 plus the big C times e to the negative 1 over x power. Now this part right here, folks, this is my general solution. Okay, general solution. Okay, and so now what I want to do is I want to use my initial condition, plug in my x, plug in my y, and then evaluate and solve for C. Okay, so let's go ahead and come back up here, and I've got my initial condition here, so I'm going to say that x is equal to 1 and y is equal, no, crap, that's not right. X is equal to 2, y is equal to 1, okay? And so I'm going to use my general solution, so I had y was equal to negative 3 plus the big C times e to the negative 1 over x. Okay, and I'm going to plug in 1 for y. So 1 is equal to negative 3 plus the big C times e to the negative 1 over 2 power. Okay, and so now we have to solve for C. Okay, and bear with me, this might get a little tricky, but it's not too terrible. So let's look at this. Let's look at, okay, let's go ahead and just add our 3 to both sides. And so we get that 4 is equal to the big C times e to the negative 1 half power. Now let's rewrite that as 1 over e to the positive 1 half power, okay? Because I'm just trying to isolate C. Now what I would do to get rid of 1 over e to the 1 half is just multiply by e to the 1 half power on both sides. Okay? And then we're going to get that the big C is equal to 4 times e to the 1 half power, which is really just 4 times the square root of e. This is my value for C. Okay, so now I want to write my general solution with my value for the big C. And so we end up getting that the big C is equal to, we get that the y is equal to negative 3 plus the big C, which is 4 times the square root of e, times e to the negative 1 over x power. And you could really simplify this down a little bit. But, right now I'm not really too concerned about that. This is your particular solution. All right. You could get away with this. You could combine these two values for E, but, I'm not too concerned about that. So, all right, let's take a look at the next problem. So on this next problem for example 3, I have this differential equation, dy dx is equal to 4x cubed times y plus 12x cubed, with an initial condition of y sub 1 is equal to negative 5. So let's go in and take a look at this. And so this is a little bit tricky, because I'm trying to get all my x's on one side and get my y's on the other. So, but that, in the other problems, that was a pretty straightforward process. Here, we have to manipulate this a little bit. Okay, so I'm going to write dy dx is equal to, what I can do here, folks, is I can factor out a 4x cubed. And so if I factor out a 4x cubed, I'm left with 4x cubed times y plus 3, okay? Now, at this point, I can divide both sides by y plus 3, which is essentially just multiplying by 1 over y plus 3 here. And I can move my dx to the other side. And so now I get 1 over y plus 3 dy is equal to 4x cubed dx, okay? And so now, I've separated my variables. I want to integrate both sides, all right? And so I think this is the same one that we had on the other one. So we already know that this antiderivative is the natural log of the absolute value of y plus 3. And then the antiderivative of 4x cubed is going to be 4 times x to the 4th power divided by 4, and then plus c, okay? These 4's divide out. And so we are then left with the natural log of the absolute value of y plus 3 is equal to x to the 4th plus c, okay? So now I want to get rid of this logarithm form. Let's rewrite this as log base e of the absolute value of y plus 3, and this is equal to x to the 4th plus c. All right, so to get rid of my absolute value, I'm going to take my e here, my base, move it to the other side and make this part my exponent. So I get the absolute value of y plus 3 is equal to e raised to the x to the 4th plus c power, okay? Now, I'm going to rewrite this part over here. We're going to get e to the x to the 4th power times e to the c, okay? And this is all equal to the absolute value of y plus 3. Remember that if I rewrite this part here as this, the reason why is because if I combine these as into one term, okay, because I have the same base, I add my exponents. So that's what I'm doing here, so we have to go backwards to get this. Now remember, e to the c is going to give me a number. So I'm going to call this the big C. And so now what we end up getting is we get the absolute value of y plus 3 is equal to the big C times e to the x to the 4th power, okay? I'm going to take this and move it up here so we can continue the problem. And I'm going to even move it further up. Sorry about this. Sorry. Trying to save some space here. All right, so we've got the absolute value of y plus 3 is equal to the big C times e to the x to the 4th power, okay? So now what I want to do is I want to get rid of my absolute value symbol. So I'm going to drop the absolute value. I've got y plus 3 is equal to, now we have to do plus or minus the big C times e to the x to the 4th power, okay? Okay, so now what we can do is we can say, all right, we can subtract 3 from both sides, and we can get that y is equal to negative 3 plus or minus the big C times e to the x to the 4th power, okay? Now, we have to determine what sign we're going to use on the big C, okay? And so what I look at up here is my y value here. Now, I notice that my y value here, so the y value is negative. So we choose the negative c, okay? So we're going to choose the negative one. So I've now got y is equal to negative 3 minus c times e to the x to the fourth power, okay? And so now what I want to do is I'm going to plug in, all right, and this is my general solution for this, okay? This is my general solution, okay? And so what I've got now is, I've got, oh crap, what is it? 1 for x, so x is equal to 1, and y is equal to negative 5. So now what I'm going to do is I'm going to plug these in. So I've got negative 5 is equal to negative 3 minus the big C times e to the 1 to the fourth power, okay? So as I do this, I've got negative 5 is equal to negative 3 minus the big C times e to the first, which is just going to give me e. All right, I'm going to go ahead and add 3 to both sides. And so we get that, negative 2 is equal to negative c times e to the first, okay? Now, what I want to do is I can divide by, negative 1 if I want, and we get 2 is equal to c times e to the first, okay? And I'm going to divide by e. So I end up getting that my big C is equal to 2 over e, okay? Now, I take this and I plug this back into my big C of my general solution. So my particular solution is going to give me y is equal to negative 3. Now minus, we have to choose that negative value, minus 2 over e times e to the x to the fourth power. Okay? And that's it. Okay, this is my particular solution. All right? Now, I do want to note, particular solution. I do want to note here, guys, that the way that I'm doing this is what works for me. Okay? I go through this process the same way. Okay? I always write this out. I get my big C. You can kind of choose, once you get to this point here, you can choose whether you want to use positive or negative, or you can kind of choose it in the next step. So I would advise into kind of maybe playing around with the numbers, seeing when you can plug things in, when you can't. There are some other ways of doing this. It's just that this way works for me every single time. And when something works for me every single time, I do that version until I figure out a better way to do it or something that makes a little bit more sense to me. So when something works, I try not to fix it, okay? So that's all I've got for this. I hope you have enjoyed this. This is Es Muy Importante, and we will see you later. Bye!